Assalamualaikum. We are from Group 5 and will be presenting about Part B from our project. Our group member consists of 4 members, which is Nick, me, Hazim, Ilhan, and Hidayat. And next slide is we will show you the list of content for our presentation. And here is the question from Part B that I will show you our problem solving, which is how we solve this question using Excel. And we will explain on how we do this calculation. For question number 1, we just use this formula, which is fixed formula for available energy in water, which is efficiency times volume of water times density of water times gravity and height. And we'll get the answer which is 608,506.5 joule. And for the question number 2, we assume the pipe is made of concrete and its friction is 0.05. Next, we need to find the heat available, which is heat minus heat loss. Before we find the heat available, we need to find the heat loss, which is unknown. So we will use this formula, F times L times Q power of 2 over 12 D power of 5, which is D we can get from this formula 0.62 times Q, flow rate power of 0.48, and we'll get 1.3424 meter, which is the diameter. And we will put the value into the heat loss formula, and we will get 0.323 meter, and heat available is 15 minus 0.323, and we get the 14.677 meter. That is how we calculated the number 1 and number 2 question. So I will pass to the next presenter, which is Hazim, and he will explain more on the power and graph about the water reservoir, which is decreased 1 meter per year. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Tahir, and in this slide we're going to solve question 3 and question 4, where question 3 asks us to find the power generated by the hydroelectric system, and question 4 asks us to plot the graph of the water level when the water is declining 1 meter per year. As for question 3, we know that power is equal to energy over time. In this case, energy is equal to available energy, where available energy we have calculated before. We didn't get the time from the question, so we need to solve and find the time by ourselves. So how to calculate time? Time is equal to volume over flow rate, where volume is 60 meter cube and flow rate is 5 meter cube per second. When we divide those two, we can get the time, which is 12 seconds. By knowing the time, we can know the power output. By dividing the available energy with time, 12 seconds, the power output will be 55.08 kilowatt. In our spreadsheet, to calculate the time, we'll just write equal to B2/B4 at the formula bar. And for the formula output, we write equal to B7/B16, and that will give us the correct value of the power and the time. For question 4, in order to plot the graph, first we need to have table, where the table consists of 2 columns, which is years and available heat. So for the first year, the available heat is actually the same as the available heat that we have calculated before. So next, for the second until the 5 years, we need to deduct 1 meter over the year. So when the table is fully completed, we can insert the graph of the table. So the y-axis of the graph will be the available head, and the x-axis of the graph will be the year. So for the graph, we can also add on the title, which in this case, the title is available head for the system in 5 years. Besides, we can also change the color of the graph. In this case, we've choose the blue color for the graph. I think that's it from me. I'm gonna pass the floor to the next presenter. Thank you very much.
Thank you, Brother Hazim. So now I will explain the several options that you could consider to maximize the power output from a system. So the first one is to increase the efficiency of the system. By increasing the efficiency of the system, you can reduce the amount of energy that is wasted and increase the power output. This could involve optimizing the system design, using more efficient components, or implementing more effective control strategies. So the next one is you can increase the power output of the system by using more powerful energy source such as larger battery or higher voltage power supply. You can also consider using multiple energy sources in parallel to increase the power output of the system. As for example, you could use a combination of solar panels and a wind turbine to generate electricity. So increasing the load also can help to increase the power output. However, be careful not to exceed the maximum power capacity of the system, as this could damage the components or cause the system to fail. Last but not least, optimizing the operation of the system can also increase the power output. This could involve adjusting the operating conditions, as for example, temperature and pressure, or implementing more effective control strategies to better match the output of the system to the demand. So, Brother Hidayat will continue the conclusion and the result. As a result, we found that the available energy in the elevated water volume is 6.6 megajoules, and the available heat for the system is 14.67 meters. The results also indicate that the water's height and the system efficiency are the main factors that contribute to the available energy. It is also essential to consider the decline of the water reservoir level, as it directly affects the available heat and the power output. So, as the conclusion, we found that the factors that affect the hydroelectric power output is the water's height, the system's efficiency, and the decline of the water reservoir level. This hydroelectric power analysis has shown that the hydroelectric power is an efficient and renewable energy source. The system's available energy, heat, and power output can be calculated and analyzed using provided formulas and data used in this analysis. That is all from our Group 5. Thank you.